This is section 2.4 in pre-calculus. We're talking about solving radical equations and also absolute value equations. So in general, to solve a radical equation, and keep in mind, a radical equation is one that has a square root symbol. So first you want to isolate the radical term, meaning get that square root by itself, so that you can square both sides. Okay, so let's start there. So for example, on number 1, I want to get that square root by itself. So I'm going to subtract 8. So 1/2 square root of x equals -3. And then to get rid of the 1/2, I'll multiply by 2. So the square root of x equals -6. And then the whole idea is now I can square both sides. So I'm going to have square root squared just cancels. So x equals -6 squared is 36. Now in this case, once I squared both sides, I was done. But up here, it might be that you square both sides and you still have to go on to solve for x. And then the one thing that we'll mention is, in general, you have to check for what we call extraneous solutions. Extraneous solutions. And I kind of qualify this. Extraneous is like extraneous. In other words, it's extra wrong answers. So we would say an extraneous solution occurs when you solve an equation to get a solution algebraically, but when you check your answer in the original equation, it doesn't work. So in other words, you get a wrong answer. And if it turns out that all of your solutions are extraneous, meaning if none of them actually work out when you check them, then you would have no solution. Now, I don't want to get too picky about this extraneous solution. So for now, let's just focus on the solving, and then I'll kind of point out something to you about when this actually happens, and it'll kind of, I hope, save you some work in the end. Okay, so let's look at number 2. If I want to solve, I want to get that square root by itself, so subtract 1. So the square root of 3x minus 8 is going to equal 2. Remember, the whole point now is to square both sides. So 3x minus 8 equals 4. And now you can easily go on and solve for x, right? I will, let's see, if I add 8, I'm going to get 12, and then divide by 3. So I'm going to get 4. Okay? Now, those are very simple. Those are very basic. We would probably do that kind of a solving problem in Algebra 1. Now let's step up to problems like number 3 and 4. Notice you have multiple square roots in the problem. Well, I'm going to stick with my plan, get the square root by itself. And you might say, well, which square root? And the answer is either one. So just get one of the square roots by itself. In this case, number 3, they're both by themselves. Okay, so now I can square both sides. And so I'm going to end up with, on the left, the square cancels the square root, and I just have 2x minus 1. On the right, the square cancels the square root, and I have 5x. So in this case, everything worked out kind of nice and neat, right? So I'll go on and solve. I'm going to subtract the 2x. So 3x equals -1, which means x equals -1/3. Okay? Now, be careful on number 4. You could say to yourself, well, this square root of 2x plus 2 is by itself. That's true. So just be careful when you square both sides on this one. On the left, you have to square the 2, and you also have to square the square root. So you're actually going to have 4, and then when you square the square root, it's just x. And on the right side, the square will cancel the square root, and you just have 2x plus 2. So again, now I can finish my solving. I'll subtract 2x, and then x equals 1. Okay, and both of those we probably would have done in Algebra 2, right, where you square both sides, everything kind of works out nice and neat. Now, number 5 is very similar to 3 and 4. Again, because the right side is by itself, you could go ahead and square both sides. If you don't like the idea of squaring a 1/2, then it might be that before you square both sides, you want to multiply by 2. So you'll actually just have the square root of 4x equals 2 times the square root of 2x minus 2. Again, you don't have to do that, but if you prefer to do that so you don't have fractions. So now when you square both sides, on the left, you're just going to have 4x, and on the right, keep in mind, you're squaring that 2, and you're also squaring the square root. So you would have 4, and then when you square the square root, you're just going to have 2x minus 2. So if you finish solving, you're going to have 4x equals 8x minus 8. And if I were to subtract that 8x, I'm going to have negative 4x equals negative 8, or x equals 2. Okay, so now we're going to kind of jump into the next level. So when we get to number 6, you want to get the square root by itself. So on number 6, you have your 2 square roots, and you do have the one on the left by itself, so it's okay to go ahead and square both sides, but here's where you're going to have to be careful. When I square both sides, okay, on the left, no problem. You square a square root and it cancels, and you just get 3x plus 16. But on the right, you can't just square them separately. Remember how we've talked about the idea that if you have like x plus 3 and you square the whole thing, that is not the same as just squaring the first and squaring the last. That's not the same. You can't do that. So you can't just say that this is going to equal you can't just say it's going to equal 3x plus 4. It doesn't work that way. You have to do that FOIL thing. You know how you multiply it out? So if I do the thing where I square it out, that means I would square the first. Well, if I square the square root, that's just 3x. And then remember, the middle term is always double the product. Well, the product is 2 times the square root. So if I double it, it's going to be 4 times the square root. And then the last is the 2 squared, so plus 4. Okay, so that was me, squaring it out. So now you're saying to yourself, I still have a square root. Okay, so you have to start over again. That means you have to get that square root by itself. So I'm going to focus on getting this by itself. So if I subtract this 3x, do you see that it'll subtract from this? If I subtract this 3x from that 3x, it's just going to cancel. If I subtract this 4, if I move that over and subtract that from the 16, I've got 12. So here's where I am. I have 12 equals 4 times the square root. And if I want to, I could square both sides, but it might be easier to, whoops, I don't know why I wrote 36. Sorry about that. That would be 3x, right? 3x. So, but it would be easier to divide by 4 first. So if you divide by 4, you're going to get 3 equals the square root of 3x. Now it makes sense to go ahead and square both sides. So you're going to have 3x equals 9. And so now when you solve for x, you'll just divide by 3. So x equals 3. Okay, so when you have multiple square roots, you still want to get one of the square roots by itself, but if after you square both sides you end up with a square root, you're still going to have to square both sides again. All right, so let's try number 7. All right, do you see that the square root on the left is by itself? So I'm going to go ahead and square both sides. So on the left, I'm just going to have the x minus 1. On the right, in order to square this parenthesis, I've got to square it out, right? I've got to use my my special product. So I'm going to square the first. So when I square the square root, I just have x plus 2. And then double the product. Well, the product is 1 times the square root. And if I double that, it's going to be 2 times the square root. And then when I square the last, 1 squared is just 1. So again, do you see this is a situation where I still have a square root? So that means I'm going to get this square root term by itself. So I will subtract that x. So that's going to cancel the x's. I actually have 2 and 1 is 3, so I'll subtract 3, and I've got negative 4 equals 2 times the square root. Okay, so again, you could square both sides, but I think I'll go ahead and divide by 2. So negative 2 equals the square root. So now I can square both sides. And I'm going to have x plus 2 on the right equals 4 on the left. So x equals 2. Whoops. Okay. All right, so let's look at number 8. Again, I have a square root by itself, so I'm going to go ahead and square both sides. So on the left, x minus 16. On the right, so I've got to square it out. So square the first. So if I square the square root, I just get x. Double the product. Well, the product is going to be negative 4 times the square root of x. So if I double it, it's going to be negative 8 times the square root of x. And then square the last, so plus 16. Okay, so I'll leave the negative 8 square root of x over there. If I move this x over and subtract it, it's just going to cancel. And if I subtract the 16, I'm going to get negative 32. So I'm going to go ahead and divide by 8. So positive 4 equals the square root of x. And so if I square both sides, I'm going to have x equals 16. Okay? So that was solving square root problems. Now let's talk about solving absolute value problems. And this is exactly what you would have done. Actually, you would have done this both in Algebra 1 and in Algebra 2. So when solving absolute value equations, you should always write 2 equations. Okay, so remember, one equation in this case would be x minus 5 equals 7, and the other equation would be x minus 5 equals negative 7, because the idea is this number could either have equaled positive 7 or negative 7, and then when you take the absolute value, it'll still give you that positive 7. So that's why we write the 2 equations. Then you solve each one separately, so either x equals 12, or x equals, if I add 5, negative 2. So basically you write your 2 equations and then solve each one. Now, you don't want to write your 2 equations, I'm looking at number 2, you don't want to write your 2 equations until you get the absolute value by itself. So first, if I divide by 5, I'm going to leave this as an absolute value. If I divide by 5, I get 9. Now that this absolute value is by itself, I'm ready to write my 2 equations. So either 5x minus 10 equals 9, or 5x minus 10 equals negative 9. So divide, let's see, add 10 and divide by 5. Over here, if I add 10, I'm going to get 1 and divide by 5. So again, I always get the absolute value by itself first. Okay, so on number 3, if I get the absolute value by itself first, I've just got the absolute value equals 13. Now that it's by itself, I can write my 2 equations. So either 3x minus 2 equals 13, or 3x minus 2 equals negative 13. Solve each one separately. So if I add 2, that's 15 divided by 3. Over here, if I add 2, that's negative 11 divided by 3. Now, keep in mind, here's where I know you're going to just kind of keep flying through this and start ignoring me, but here's where people tend to make mistakes when they're showing their work in their homework or on tests or quizzes. Notice my first step before I wrote my 2 equations was to get that absolute value by itself. Okay, over here, my first step was to get that absolute value by itself. What happens is a lot of people tend to get it by itself and they go straight to this equation and then they mess up writing their second equation. I'm just telling you, if I were you, I would get the absolute value by itself first. Okay, now on number 4, this is one of those special cases you need to catch. Yes, the absolute value is by itself, but look at it. I can tell you right now before I do any math, the answer here is going to be no solution. Why is that? Because is there any way an absolute value can equal a negative? No. Absolute value can never equal a negative. So automatically I can just say no solution. Okay? Number 5. All right, you're like, oh, there's x's on the other side. That's okay. You follow the exact same plan. The absolute value is by itself. Check. So I'm ready to write my two equations. So one equation is going to be 2x plus 12 equals 4x. And the other equation is going to be 2x plus 12 equals negative 4x. I do exactly the same as I did up above. So now when I solve, let's see, I'll subtract 2x. So 2x equals 12, or x equals 6. Over here, it doesn't really matter. If I move the 2x to this side, it's going to be a negative 6x equals 12. So x equals negative 2. Okay. So let's look at number 6. Let me squeeze that up. Okay, so on number 6, again, write your two equations. So either, now at this point you might be saying, hey, is this like number 4 in that the absolute value equals a negative? But just because the absolute value equals negative 3x doesn't mean the absolute value equals a negative, because maybe x is a negative number, in which case you would have the absolute value equals a positive. Okay, so I can't just automatically say no solution, because negative 3x is not always a negative number, whereas up here, negative 5 is always a negative number. Okay, so I'm still going to follow my pattern, write your two equations. So 2x plus 5 equals negative 3x, or 2x plus 5 equals positive 3x. So I'm going to, let's see, if I move the 2x over here, negative 5x equals 5, x equals negative 1. On this side, if I subtract my 2x, I'm going to get x equals 5. Okay, so you may or may not remember this absolute value stuff. Let's see, these are all very much similar. You know what, let's take a look at number 8. Again, these are both the same. Let me show you number 8, and we might not need to do both. So before you can write your two equations, I'm looking at number 8, you have to get the absolute value by itself. Okay, it is. So in this case, notice I have stuff on the other side. You're still going to follow the same pattern. Either 2x minus 9 equals exactly what you have on the other side, or 2x minus 9 equals negative of what you have, meaning negative of the whole thing. So if it's negative of the whole thing, it would be negative 3 minus 5x. Okay, so it's positive the entire right side or negative the entire right side. It's not just changing one of the signs. Okay, so to finish solving, let's see, I'm going to do this. I'm going to move the 2x over here. So when I subtract, that's 3x. I'm going to move the 3 over here. So when I subtract 3, that's negative 12. So x is negative 4. Okay, or on this side, I think I'll move the 5x over here. So when I add it, that's 7x. I'll move the negative 9 over here, so I'll be adding it. So that's positive 6. So x equals 6/7. Okay, you know what? I think it's probably better if we go ahead and do number 7. But I liked that we did number 8 first. So now on number 7, can I write two equations? Well, not yet. What do I have to do first before I can write my two equations? Don't I have to get the absolute value by itself? So if I'm going to get the absolute value by itself, I'm going to write absolute value of 3 minus 5x equals, I'll move that 7 over, so it's negative 7x minus 7. Okay, so write your two equations. Either 3 minus 5x equals exactly what's over there, or 3 minus 5x equals the opposite of what's over there. Well, negative of that whole thing would be positive 7x plus 7. Okay, so just to finish this out, I'll go ahead and solve. So how about if I'll move the 5x over here. So you know what? I changed my mind. I don't want to do that. I want to move the 7x. So I'll move that 7x over here. So I'll be adding it. So positive 2x. And then I'll move the 3 over here. So I'll be subtracting it. So negative 10. x equals negative 5. On this one, I'm going to move the 5x over, so 12x. And I'll move that 7 over, so I'm subtracting 7, so that's negative 4. And if I divide both sides by 12, x equals negative 1/3. Okay? Now, I did all of this solving on both the square roots and the absolute values, and you might be thinking, okay, what was that extraneous business? Okay, that extraneous solution business. And basically what that means is I should have taken every single one of my answers and checked it in the original equation. You always have to check in the original equation to make sure it works. Okay, but let me show you something. Okay, you really don't have to go through that much. Look at number 3 up here. Okay, so remember my original equation was this stuff before I squared both sides, right? So my original equation was before I squared both sides. And so when my answer was negative 1/3, technically what you should have to do is plug negative 1/3 in place of each of these x's and see if you end up with the same on the left as you end up on the right. See if they really are equal. But here's a kind of something to save yourself on. Do you see that if we were to put a negative 1/3 in for that x, do you see that I would be taking the square root of a negative? And anytime you're taking a square root of a negative, that means that solution is not going to work, because we don't want imaginary solutions on these. Okay, so if you were to plug in and you would end up taking the square root of a negative, then immediately you say that one is not part of my solution. And on number 3, since that was the only solution I got and it didn't work, you would say no solution. Okay, so just to kind of show you, so remember we're going back into the original equation. So on number 4, if I were to plug a 1 in for x, well, if I put it in there, that's okay, right? You're not going to have imaginary. If I put a 1 in there, that's okay. You're not going to have imaginary. So you don't even have to go any further. It will work, right? The only time it's not going to work is if you end up with an imaginary number. So you don't have to worry about it. That's going to work. Okay. Let's see. Go down to number 6. Do you see that the only answer I had was 3? If I put a 3 in there, that's fine. There's no imaginary. If I put a 3 in there, that's fine. There's no imaginary. So a helpful hint is a lot of times the only ones that might not work are solutions that were negative. That doesn't mean every answer that's a negative doesn't work, but those are the only ones I would even really check on. So like on number 7, since you only had a positive answer, I wouldn't even worry about checking it. Or on number 8, since you only had a positive answer, I wouldn't even worry about checking it. And technically, the same is true on absolute value, that you should have to check for you should have to check for extraneous solutions. But here's your helpful hint on these. Again, what you should do is plug it in and see if it actually works, just to kind of show you what I mean on this one. So on number 3, let's say I'm going to check x equals 5. So that means if you put a 5 up here in place of x, everywhere you see an x, you would have the absolute value of 15 minus 2 plus 2 equals 15. Is that a true statement? Is the absolute value of 13 plus 2 equal to 15? Well, yeah, it is. It works. But I don't want to go through all that work. Okay, I don't want to have to go through all that work. So I'm telling you, the only time that you even have to check is if you had x's on both sides. Do you see how on these you have x's on both sides? But up here on number 3, there were not x's on both sides. On number 1, there was not x's on both sides. On number 2, there was not x's on both sides. So you don't even have to check 1, 2, and 3. Now, on these down here where you have x's on both sides, again, the only ones that I would even check on are the negative. So just to kind of show you, on number 5, if I were to put in a negative 2, do you see that if I were to put a negative 2 in for x, do you see that on this side I would have a negative 8? Is there any way that the absolute value can equal a negative? No. Absolute value always has to be positive. So all you have to do is look at that to say that one doesn't work. But 6 is fine. So I'm not going to say no solution because I still have a different solution. Okay, on number 6, so let's check the negative. If I were to put in a negative 1, Oh, in that case, this would be a positive, right? So that means it's okay. But be careful on this one. If I were to put in a 5, do you see that this side would be negative? And there's no way an absolute value can equal a negative. So in this case, it was the positive solution that didn't work. You might be like, oh my gosh, so I have to check all negative and all positive. Well, you really only have to check them if you had an X on the other side of the absolute value. Okay? And again, I don't want us to get all bogged down in having to check everything, but I wanted to point that out because on standardized tests, you might have to know that. So really in here, I probably won't even make that big of a deal about checking them. Okay? And this is just explaining what I just talked to you about. The only time you have to check it is if there's X's on the other side. All right. So that's a pretty long explanation of section 2.4.